Khalid Benhamou. Khalid, you are, let me introduce you first. You are the treasurer of the World Wind Energy Association, as that's a voluntary role. Your main role is managing director of Sahara Wind, and you will speak about now the broader regional context and about how green renewable hydrogen can be a basis for the economy of the MENA region. And I assume that you will also speak about the potential relation with Europe. Khalid, the floor is yours.
Thank you, Rosh Stefan. I take this opportunity to praise my previous presenter, and I'm happy to see that green hydrogen technologies are actually at the backbone of the region's current energy transition. In order to build such a strategy, I must say that we have started. It's a highly strategic issue because we're talking about an energy transition, and we've been able to mobilize funding from NATO because we're talking about an energy transition and energy dependency from countries within and outside of NATO, neighboring countries. And it is indeed with the help of the phosphate conglomerates in 2006 that we have actually managed to mobilize funding from NATO on the green hydrogen and green ammonia in particular. And I'm happy to present during this short time that I've been given to show you how these two are connected. For that, I'd like to go back over a paleontological map of the planet some 15 million years ago and show you how actually renewable resources and their fossil footprints will enable you to achieve this transition. What you've seen here on the map is the circular wind flows, the trade winds over the Atlantic, which over the surface of the Atlantic generate the currents, and this has pushed and concentrated lots of plankton on the shallow bassins of emerging North Africa. You can see Europe. And this has concentrated a very rich biotope. And the bone remains of this biotope is actually at the origin of 72% of the world's sedimentary phosphate reserves. So we're essentially going to use the trade winds again to process these phosphate reserves into fertilizers. And basically the trade winds are still blowing today. And what you see on the map here, the white arrow, they blow over 2,000 kilometer long desert seacoast. And in that desert seacoast, you can install over 6,000 gigawatts, more than 6,000 gigawatts, because we enclose also parts of Mauritania. And you can generate, in the vicinity of 11, 12, 15,000 terawatt hour of electricity generated at a very low cost because of the capacity factor of about 60% of the wind. So we have an outstanding resource. The main challenge, of course, is how to access that resource for both North Africa, Europe, and of course, Sub-Saharan Africa. And that is why we're going to mobilize actually the loads in the region, which are namely the desalination station, and the other loads are in fact mine processing. What are we processing? We're processing phosphates and we're processing iron ore. There are huge iron ore deposits in Mauritania. I'm going to highlight how these can integrate hydrogen technologies to produce clean steel. There's also lots of deposits in southwestern Algeria, and so it's critical that we be able to transition in these clean steel technologies in order to ensure that in fact the access to the wind resource can be facilitated by hydrogen technologies. And this will ultimately help the balancing of HVDC line, which will enable North Africa to access a very cheap wind resource. And in the future, thanks to the balancing and to the flexibility that hydrogen storage provide, we can have a future green hydrogen pipeline, which will then extend to Europe, to European energy markets, and of course, European green hydrogen pipeline and gas infrastructures. So the way we should go about it is you have right now in yellow the AC network, fairly weak. The majority of Morocco's operational wind capacity is located in that region, 800 megawatt out of a total of 1,200. And the idea is to add an electrochemical loop which can then produce green hydrogen for ammonia. And in the same way, if you use chloralkali technology, you can also process phosphate into phosphoric acid, which is the way the plant takes up the fertilizer. And if you do so, as I had mentioned, you'll be able to balance and gradually build up the capacity for a regional HVDC line to supply regional markets, and in particular, Morocco's load centers that are located 1,200 kilometers from that region. So AC networks will not be able to facilitate efficiently and at low losses such transfer. Equally, for Mauritania, the iron ore export business of Mauritania, which is 15% of that country's GDP, 50% of the foreign income revenues of Mauritania comes from the iron ore export, and that will enable that country to access wind electricity and gradually to build up its grid to feed sub-Saharan African markets, electricity markets with very cheap wind electricity, where may I remind you that over 600 million people do not even have access to electricity. And so the Mauritania iron ore industry is really a compelling business case because the company that is the state conglomerate that is operating the iron ore export has already experience in both wind turbines, electric arc furnaces, induction ovens. The only missing part is the electrolyzer. And this is what we have done already in 2011. We have sent the first wind electrolysis system to Mauritania, a second one to Morocco, so that we build capacity on these electrolyzer technologies. The process of producing steel from iron is very simple. You can use hydrogen direct reduction to transform the iron ore into sponge iron, and then with induction ovens and electric arc furnaces, you can transform that sponge iron into steel. And that whole process is being made in a carbon emission-free way. So you have to see that steel is responsible for close to 5 to 7% of the world's entire CO2 emissions. So interestingly enough, in the region, you have a 100 megawatt wind farm that will come online at the end of 2020. Mauritania's grid is fairly small. It is less than 1 gigawatt. It's 500 to 700 megawatt big. And so, of course, if you add large wind capacity, you have an operational balancing of the AC grid. And if you manage to do that, you can then gradually process Mauritania's iron ore exports into a value-added CO2 emission-free steel business. And so the capacity that we built in that region were critical. We have actually launched Africa's first wind hydrogen project. It was on a 30 kilowatt alkaline electrolyzer. Similar one, as I said, was sent to Mauritania. And this was essentially aimed at training capacity, training engineers, building the systems, the knowledge, the expertise needed for handling intermittent power fluxes into weaker grids. We also used that to power telecom towers, with which we conducted the regional wind measurements in Mauritania and Morocco. And we also engaged in an industrial engineering program on small wind turbines because they are more accessible, obviously, in college campuses. And so Morocco's phosphate industry is really a compelling case. It is Morocco, because of its reserves, is the world's first producer and exporter of phosphate products, 31% of global market share. In some of those items, phosphate rock and the processing of phosphate into phosphoric acid and fertilizer, you are reaching, for the phosphoric acid business, for example, 50% of the world export market shares. So those are significant. And this industry relies, for the fertilizer part at least, relies heavily on gray ammonia imports. So you have a need for ammonia locally, and the opportunity to then use outstanding wind resource to produce green hydrogen and then green ammonia subsequently is very compelling. And it's also important because you are essentially using a resource, the phosphate fertilizer. Phosphates is non-substitutable, and so it is a highly resource-efficient process. And I can let you imagine how important that will be for global food security. And if you look at the ammonia synthesis as well, you are already transitioning a fossil-based business into a renewable energy, sustainable process and industry. The ammonia synthesis consumes anywhere between 2 to 3% of the world's primary energy demand. So it's huge. If you add urea product, you reach about 3% of the world's primary energy demand. And so you have here the world's largest phosphate player that can transition into these clean technologies. About the wind technical potential of 6,000 gigawatts, it's obviously an onshore potential, and it's larger than 6,000 gigawatts. I'll let you imagine that you can add a third of that potential offshore in addition to that onshore potential, but that involves higher cost. Obviously, you're not limited by the availability of land on the Sahara Desert coastline, which is essentially a rocky desert. And so you do not have a big problem setting up wind turbines, as is currently the case for about 800 megawatts of the operational capacity. The Morocco-Germany landmark agreement signed on June 10th aims precisely at doing two things: an ammonia demo plant. This has been mentioned by the previous speaker. Essentially, it looks at simulating in a realistic intermittent operation and on the industrial scale the production of ammonia using intermittent renewable electricity, mainly wind, because of the capacity factor. You have a double, 2.5 more production of wind than solar. Both will be needed, obviously, but the bulk of the energy will come from the wind energy. And so that will enable the region, in fact, I'm wondering, okay, this will enable the region to basically, with also desalination for agriculture, which is actually, and for the supply of the cities, would provide a sustainable water source for the region, which is the main priority for the region, Morocco and Mauritania as well. And obviously, the phosphate and iron ore to steel business cases will enable the electrolyzer business to firm the capacity locally to power an HVDC line. And then ultimately, with the pipeline network, it will enable us to produce, obviously, seasonal storage and fuel 100% clean energy transition in the case of Morocco and Mauritania. So this is what I have to say on the western part of the MENA region, which I believe is well on track to transition into clean energy prospects. If you look at the eastern part of the MENA region, namely the Gulf, it's hard to talk about Gulf countries if you do not mention Saudi Arabia, which is obviously the largest, most powerful country in the region, and its onshore potential is fairly significant, although not as big, obviously, as the trade winds blowing over the Sahara coastline. But what is important here is the policy of the government, which is very proactive. 9.6 gigawatts targeted by 2023. And most recently, Saudi Arabia's energy minister, Prince Abdulaziz bin Salman, announced that the kingdom will produce 50% of its electricity from renewables by 2030. That roughly is equivalent to about 40 gigawatts of renewable electricity to come online in that kingdom. So when you look at the numbers, the last tender of 400 megawatts that has been attributed recently, will be completed in 2022, has been attributed at 2.13 cents. It's essentially the world's cheapest wind electricity, thanks to Saudi Arabia's mighty financial resources. Obviously, the next speaker was going to talk about the world's largest green hydrogen facility to come on stream by 2025. And it's essentially a 5 billion world-scale green hydrogen-based ammonia production facility that will be powered by anywhere between, that will be powered by about 4 gigawatts of a combination of solar, wind, and storage. So that will produce 650 tons per day of hydrogen, green hydrogen, and green ammonia, 1.2 million tons per year, which will be integrated into Air Products, which is the leading supplier of ammonia, of gray ammonia. They will then dispatch this ammonia in their supply base, and that is very encouraging because we have a major fossil fuel actor which is transitioning proactively with significant investment. I think it's the largest renewable hydrogen investment to date into green ammonia and green hydrogen. And last but not least, I want to conclude with the wind map of Saudi Arabia and Egypt, and to show you that the wind resource lies essentially along the Red Sea. The project is located at Neom, and what is very interesting to note is that this site is actually located on the node of a 3 gigawatt HVDC line connecting Gulf countries, Saudi Arabia, mainly to Egyptian power networks. And it shows you the complementarities between green molecules and green electrons, which are likely to sustain the energy transition and the future renewable economy of the MENA region, both in the East and in the West. And with that, I'm happy to take your questions. Thank you.
Yes, thank you very much, Khalid. That was an excellent presentation, and I really appreciate that we heard from you the also industrial perspective of a hydrogen economy, which is going by far beyond fuel cell applications, but that there is a very concrete need to produce hydrogen for the existing industrial activities in Morocco and also in other parts of the MENA region.